In this episode, we'll be looking at the different kinds of test doubles and when you would use these. The term test doubles has been borrowed from Gerard Mazoris's book called Unit Test Patterns, Refactoring Test Code. Prior to that, I was following, Roy Oshrow's vocabulary, which was everything is a fake, and you either have mocks or stubs. And that's similar to what Martin Fowler talks about in his blog post, Mocks Aren't Stubs, where you're either a mockist or you're a classicist, as in you either do the classical style of unit testing or you're doing the mocking style of unit testing. And so Roy called everything a fake. When I read Gerard's book, I found that he had a larger or a wider taxonomy for these things, and then the term he used was test doubles. And then he had a bunch of them, there's quite a few of them in fact. And so what I did was I tried to align the names for the kinds of stubs that I had into the slots or the names that he had. And that's what you're going to see here. So the idea is that there were different kinds of stubs. So when I was doing the stubbing style of unit testing, everything was a stub, and it didn't matter whether the stub was slightly different or not, it was a stub. And over a period of time, I found that there were essentially different kinds of stubs. You use a stub to do different kinds of things to help you with your unit testing. And so I tried to align my vocabulary with Gerard Mazoris's vocabulary. I think they're pretty close, but it's not 100% there, because I guess there's a bit of a style difference or a philosophical difference in how you do testing to start with versus the names and how to use them. So in the test doubles that I introduce here, there's a very specific reason for why you would use one or the other, and they're not flexible, as in to try and introduce a discipline when you're doing unit testing. I think that's important, and I'll show you a few other scenarios where this discipline is really important. I found to provide a nomenclature for test doubles and also have fewer test doubles than one kind of test double. Like for example, in Gerard's book, he's got, let's say, a stub, and then there's variations to the stub. And I think that will be quite a bit more confusing for people, because it goes back to kind of the notion that it's a stub and then there's all kinds of different kinds of stubs. So rather than have a confusion, and also kind of distilling down from my experience with the unit testing and working with my teams, fakes, spies, stubs are pretty much everything you need. And in some nuanced cases, we also have hooks and 4 test classes. I won't be talking about the 4 test classes in this episode, and I'll try and introduce to you the hooks. They're a bit nuanced, but hopefully you'll figure that out after I explain it. So let's start from the top. So everything is a test double, and there are different kinds of test doubles. So every class that is a stand-in for the production class, as I call it, it's a test double. These test doubles obviously only exist in your unit test projects. They don't exist in your production code. Fakes are, as they are test doubles, they are stand-ins. They provide 100% functionality of the class that they stand in for. In other words, they are 100% substitutable for the real class or the production class. This is a big deal, because if you were looking at building a fake for a certain class, it would be quite a tall order, depending on the complexity of the class, to build a class that's in function 100% substitutable for the real class or the production class, and yet it's not the production class. Also keep in mind that these test doubles are only the test doubles that you would use at the leaf nodes or the seams of your system, the boundaries of your system. The approach I presented in the last video, if you haven't seen that, please take a look at that. Unit Testing Rebooted. The idea is you're not using test doubles for every class. You're not testing every class in isolation, therefore you don't need a test double for every class in your system. So the only time you need test doubles are for classes that are reaching out into the real world. So one example could be the class that talks to your database. Let's say you have a class called a data manager, and this data manager talks to your database. It does all of the functions of talking to your database. You could say you could build a fake for that, and if your system is small enough, I think that makes sense to replace the database or data manager with an in-memory implementation or version of your data manager. So when you're doing your testing, you can swap out the actual data manager with your fake. But as the system grows and the data manager is doing a lot of work, and essentially the database is doing a lot of work, meaning you've got store procs and there's a lot of work being done in the store procs, it may not be feasible to build a 100% substitutable data manager in memory. That's a lot of work. So I personally don't use data managers as fakes. I use the real data manager. Also remember, when you do use a fake for any one of your production classes, you do need to test the production class as well. So it's not like you get away from testing the actual production class. You do need to have tests. And if you remember from the previous video on Unit Testing Rebooted, I said that you probably want to have a class integration test in this specific case, in a data manager case. For that, even though you may use it through your acceptance testing, but let's say you didn't, even used a fake, you still need class integration tests for your data manager. An example of a fake that I have in one of my projects here is, let me scroll down to so under my test doubles, there's fakes, and under fakes there's service providers, and then this configuration provider fake. So this configuration provider fake is the fake for, or the test double for, the actual configuration provider, which is dependent on either a file system or some other thing, a database or whatever. But for testing purposes, you might want to use a fake. In this case, it's an in-memory version, storing all of the data in this case, a dictionary, and it descends from the configuration provider fake. So I can swap out the actual production class for the fake in all of my unit testing. So my unit tests are not dependent on some config file settings that are potentially on a physical file, and thus can be overwritten by different tests, and then your tests are not isolated. And so having a faked version of your configuration provider makes it very simple to set up the data, the config information in the arrange part of your test, so you can run your tests in isolation. So that's one example of a fake. Fakes are well tested, and by that I mean, when you have a fake, you have to ensure that the fake is 100% substitutable for the real thing. So the only way to do that is to ensure that the fake goes through or undergoes the same rigor of testing as the original class or the class stands in for. If you don't, you're not quite sure that when you swap out your production class for the fake, that you're getting the same behavior. So that's another criteria for using a fake. If you are using a fake, you have to have tests, and the fake needs to pass the same test, the same scenarios and expectations as the production class. The next test double is Spies. There's a whole video on Spies called Test Spies and Test Mediators. To keep it short here, Test Spies in conjunction with Test Mediators allow you this ability to put in or hook into observation points within your classes downstream from the classes you're testing. Essentially what mocks do. So they're a replacement for mocking without the disadvantages of mocking. Disadvantages, at least the way I see them, and I explained that in the Unit Testing Rebooted video earlier. Just to give you the highlights of Spies here, they provide the ability to spy or intercept, or to provide an observation point within some class downstream from where you're testing. And therefore they provide a means to define a response as and return values from some class that's downstream, far removed from the class you're testing. They provide a means to spy into method calls. It's kind of the same thing where depending on a certain parameter sent into a method call, your response may be different or the behavior of that spy may be different. But you can control all of that from your test mediators without really knowing that there's a test spy. So please look at that video if this seems a bit confusing. I go through a couple of code examples as well, so you can understand the purpose and benefit of spies, test spies, and test mediators. Stubs are a canned response. This is again very different from Gerard Mazoris's explanation of a stub or usage of a stub. He's got various kinds of stubs, and so far I've had just this one need where either using spies or fakes, and sometimes you need a stub, and they provide a canned hard-coded response. And by that I mean there are no conditional statements in your code. So let me show you a stub. Oops. So here's a stub class. It's unique ID determinator, and so that's the class is sort of standing in for unique ID determinator. This is a class, or the production class is determining if the ID it's been provided is unique or not. And in production, this class's implementation is calling out into the database to confirm that this ID is in fact unique or not, and if it's not, it returns a false. This specific stub says always false stub. That means this stub is always going to return a false. And as you can see, this is just hard-coded. And for a certain use case or test case scenario, I needed this where this class would just always return a false, so that I can test another scenario which says, okay, if you've tried this 1,000,000 times, then you need to make sure you throw an exception. And that's what this class is used for. Moving on to the next slide here. Hooks. Hooks are a very nuanced case. Typically you'd find that you need a hook when in one of two scenarios. Let me draw this out. So let's say you have a class here, and this class in turn talks to another class here, and you're trying to test this class. So let's call this class A. This is class B. And let's say B is not one of your classes. It's a class that you can't descend from, or there's no interface that you can implement. And it so happens that you have directly consumed B from A. In other words, A has a direct dependency on B. Now it comes time to testing A. A is doing quite a bit of functionality in A, and you could essentially just test A in isolation from B. One way to do that is to introduce a class in between these. So you can have a class here, and this is the class. So let's call this C. So A really depends on C. C is the one that's dependent on B, and you could now create a test spy in your test projects for C and intercept anything that's going in and out of C. So anything that's going in from A and coming out to C, you can intercept, and conversely you could return anything that's coming back from B that's going out to A. And that would be the classic case for a test spy. But what if you can't do that? What if you can't, or don't feel like introducing one more class now just so you can test class A? In other words, what you want to do is you want to intercept everything that A is sending out to B, and also control what's coming back from B. Class A is doing a substantial amount of work that you want to test in isolation. Again, this is one of those cases where you decide you need to test or would like to test this class in isolation. But it so happens that the dependency is one of the dependencies depending on is a class that you can't inherit from, or a seal, or a third-party class. and that's where you would use a hook. So let's say method, this class A is calling a method. Let's call it method 1. So I'm just going to call it M1, method 1. And method 1 is the one that makes this call out, right? So method 1 is actually the one that's making a call out. So method 1 has the input, and then it has a response, output. What you can do is you can descend from class A. Let's call it A prime. And you override method 1. So let's call this method 1 prime. In your unit testing, you would create an instance of this class, and you would call the method required, method A. It effectively is really, so let's not call it method A, let's call this, there's an actual method here, let's say call it a public method. Same public method available here. So when you call the public method in your unit test, indirectly it ends up calling method 1, but you've overridden method 1, so it comes in here. And in this class's method 1, you are basically seeing the incoming parameters to method 1, and you can control the response of that method 1. And therefore, in your unit testing, even though you create an instance of A prime, you're effectively using the functionality built into the parent class A and all of its functionality, but you're just hooking into this method before it calls out to some other dependency. And so you have the implementation right here, and you can use in conjunction with test mediators the same idea, where you can control what method 1 is going to receive, and based on that what it's going to respond with, so you can control the unit testing. But the reason it's called a hook is that when you're doing test spies, you're really descending from this class, as in the dependency, and then this class over here, this would be the spy. But now this one over here becomes the hook. It's just a different terminology because it's a slightly different way of arriving at the ability to do testing and hooking into some classes observation point, and being able to control the inputs and outputs of the response based on a certain input in your unit testing. So you're really creating an instance of this class. Indirectly you're testing this class, because all this class is doing is overriding this one method, but not the actual functionality of the class itself. So just before it leaves the class to make a call out to the dependency, you are getting the opportunity to hook into that, and that's why we call it a hook. The 4 test classes are similar in the sense that, again, the idea is to allow you for a hook or observation point. You may want to look at my other video on the factory method pattern, which is another Goff book pattern, where I explain the factory method, but I also show you how you could use it for unit testing. The 4 test classes are nothing but the descendant class that's called the 4 test class, that's only in your testing projects. So that covers the different kinds of test doubles. I'm going to the next slide. So there are some rules and disciplines around using test doubles. There is only one authoritative collection of test doubles in your entire test suite. If you have multiple test projects, then you would define, let me show that here. In this solution, there are multiple test projects, and so there's a shared library, class library project, in which all of the test doubles are defined. So there's only one authoritative collection, and it's in here, and they are in this folder, test doubles. That's the one discipline. The other discipline is that there can only be one kind of test double for a given production class. So if you have a spy for a certain production class, you can't have a spy and a stub, or a spy and a fake, and so on. There can only be one kind of test double per production class in your entire solution. You don't want to have, some cases I'll use for the same production class, I'll use a spy because it's easier, convenient, and then I also have a stub or a fake for the same exact production class. So that's a discipline you need to follow, and the reason is that it gets very confusing for team members, not only the current team members but also the future team members. When if let's say for example there's a certain class for which you wrote a fake, and this fake is fairly complex, but you've written a fake and it's 100% substitutable for the real thing, and everything works just fine. And then a year later I need to extend that class in terms of its functionality, and I find, oh, you've written this fake, but it's just way too much work for me to add on these 2 new features for this class and implement them in such a way that they're well tested and 100% substitutable. So I'll just use a spy for this, and this starts to, I guess, grow like a weed or a virus, where now you have multiple test doubles for the exact same class, and nobody has a clue as to what to really use or which test double to use for the test that I'm doing. So I'm just going to create my own again, and that goes sideways pretty quickly. So that's an important discipline to stick to. So the authoritative collection and shared across all test projects, they are minimal in that, this is going back to the very first part, the rebooted unit testing rebooted part also, where you are only creating test doubles for those classes that you desire or deem you need to have test doubles for, and these are typically classes that leave your system boundaries, the leaf nodes, the shared fixtures, as Ken Beck calls it. So you're not creating test doubles for every class. You're not doing every class requires a unit test metaphor of testing. You're doing the acceptance test or behavior driven testing metaphor of testing, and so you only need to swap out or use test doubles for a minimal set of classes. They are isolated in that they descend directly from either the base class or or implemented interface, but they don't descend from the production class. In other words, you don't want them to share some implementation such that if there's a bug in the production class, there's also a bug in the test double. Now there could be a case where your production class also descends from a base class that has some implementation, and yes, you can certainly descend from that base class for your test double, typically of course a fake in this case, since you're expecting to do some actual implementation, but you should not descend directly from the production class. So they should have their own implementation. So this brings us to the end of this session on the test doubles and the vocabulary in play for the different test doubles. Oh, another thing, sorry, my mistake. I want to bring this up as another discipline for the test doubles in the folders here. So notice the folder structure here. First of all, there's one folder that says test doubles. So all your test doubles are in here, in this one, in this case a shared class library. Now in this specific solution I only use fake, spies, and stubs, and so there's each of them has a folder here. Now under fakes you'll see that there's another folder hierarchy. It says managers, then it says service providers, services, and so on. Let's look at the spies. Managers, it's repeating. See, managers. There's managers, and then there's helpers and infrastructure services. These folder structures here, so after spies and the fakes, the folder structure here is mimicking the folder structure of your production project. So in this case it's this one. So if I look at the managers folder here, I can see that the managers folder has a subfolder called helpers and has a subfolder called infrastructure services, which is the same as this. If I expand infrastructure services, I'll see that there is a email service spy. If I expand the infrastructure services over here, I'll see also there's the email service base and email service SMTP. So the reason that they're following the same folder structure is that they're easy to find. So if I want to find out if there is a substitute testable for the email service, I know where to look for it. It's either going to be in the spies folder and this hierarchy here, or it's going to be in the fakes. So I can see immediately that it's not a fake. Like if I look at the stubs, I can see immediately it's not in the stubs, so it must be here. Similarly, this GUI generator spy, if you want to work backwards, the GUI generator spy is obviously going to be the original class, or the production class is going to be found in the helpers folder here, and GUI generator. So it makes it very easy for the team to navigate across folders and across these projects and know exactly where to find something. So if, for example, if I think I need a spy or some form of test double, the first thing I do is I look to see if that test double exists in either the fake spies or stubs folder. And if not, I know exactly where to place one and decide whether it's going to be a spy, stub, or a fake. Create the folder hierarchy and place my test double in that folder. It becomes very easy for the team to find their way around and ensure that they're not duplicating work or creating a test double when already another kind of test double exists. Alright, so that brings us finally to the end of the session. In the next parts, we'll be looking at the various unit testing best practices. It's not a full-blown version of best practices, but certainly some of the things I found that are very common mistakes. So I'll see you then.